write an NDA because
Yeah,
I mean this is something that could be. I don't want to have any secret from you. I just want to
yeah.
discuss the
No worries. I
uh,
understand that. Yeah, that's good. That's great. Uh,
yeah.
uh,
So we can write a NDA. We're starting today. That's okay
yeah,
with me.
sure, sure. No worries. So I'll share my screen. I'll have a quick presentation, and that would be great one, I think. Yeah. So you can see my screen.
Yes.
Sure. So here are the slide. Yeah. So my name is Abdullah, and I'm from Memorial University of Newfoundland, master's student, and I'm doing my thesis. So on photocatalytic conversion of CO2 to methanol, and so so our idea is to actually produce methanol from the process from the conversion of CO2 in order to support the decarbonization goals, and also the circular
Okay.
economy goals. So as we know that the maritime shipping industry, they receive or they face they are pressurized by the regulatory frameworks in order to decrease their in order to decarbonize the industry, and
Yeah.
uh, and a lot of CO2 is being emitted. And also there are various other processes such as direct air capture, but those are very energy intensive due to low atmospheric CO2 concentration. And so this is the flow chart of the process. Currently, I am working on this part, the photocatalytic part. So here our idea is to take the CO2, which is dissolved in seawater, and convert
Mm.
it into methanol by the water splitting reaction. So CO2 gets added up to hydrogen gets added up in the process of CO2. So it's a 6-step process, and this lead to the conversion of CO2 to methanol. And then the methanol could be used as a fuel for running the vessels. So there are companies which actually have vessels which could run on methanol, such as Maersk's order like 20
Mm.
vessels that can be
Yeah.
methanol.
Uh, yeah, I know that. Yeah.
Yeah, and also as we know that the currently the ships are LNG fired, or they are, yeah, most of them are LNG fired. So this is the idea of this is our idea. And we have our photocatalyst. So this is this is the major role player, and it helps in converting the CO2 to methanol, because there are other photocatalysts which actually helps in processing other types of target products such as methane or methanol. But this one is more focused on producing producing methanol, as we know that the methanol is the liquid fuel, and that's why. And
Just a question: when
yeah.
the ZAB, is it the name of the chemistry behind your invention, or
No, that's not that's actually just a name, and the
okay?
photocatalyst is actually a Z scheme heterojunction photocatalyst. So it's formed by from two materials. So one of them is light effective, and one of them can absorb the light photons, and one of them actually does the reactions. So that's how two materials are formed together. Yeah.
Okay, so um,
And moving
that's
on,
fine.
so our target is when we produce the two kinds of fuel, methanol and also hydrogen. So in the process, we have more and more of hydrogen produced, but as we know that the hydrogen faces like infrastructure issues and storage issues, that's why we shifted our main product to green methanol rather than
But
hydrogen.
just so your system produce hydrogen from the photo catalyst reaction.
Yes,
but then the hydrogen is reused to produce methanol.
methanol. Right. Yeah, that's
But
right.
do you also have the possibility to store or to produce hydrogen?
We can also produce hydrogen, but in that case, our target product, which is methanol, will be reduced.
Okay, reused to produce the methanol.
Yes, in that case, if we go on the other process, which is doing the electrolysis, that would be one method to actually produce more hydrogen and also integrate it with the process to produce methanol. So in that case, we can produce more methanol and more hydrogen together.
Okay, but do you think that it is better to go to the methanol
Yeah,
ra- rather than the hydrogen? Hydrogen is not so simple. I agree with
yes,
you. Methanol is a nice product. It's
yeah,
liquid. It's low risk and low
right.
pollution. So yeah, it has a lot of advantages. Yeah.
Yeah. And yeah, and that's all. And the global market opportunity of methanol, I think, which you all already know. And
Mm.
uh, these are the these are the advantages of the process, which would lead to reducing the CO2 emissions and avoid carbon. And also, we are trying to prepare like circular economy. So we have the methanol, it gets it. So the process of combustion takes place, it releases CO2, and then we can use the captured CO2 or the dissolved CO2 again. And so we have the circular economy. This is one of the major advantage to build the circular economy of carbon of the
Yeah, but
fuel
the
which we are
capture of
using.
CO2, that's another story.
Yes, capture of CO2, that's
As you
another.
said, capture CO2 is energy intensive.
Right.
So at the end, if you save 90%, but you
Mhm.
spend 120%,
Yeah.
I mean, that's not an easy equation.
Yes, that's I think that would be the another challenge to handle the energy flow, because uh, currently I'm only focusing on one part, which is the carbon utilization, but I know that we need to make it broad in order to see about the captured CO2 also. But in this process, we will more likely work on dissolved CO2, which is in the seawater.
Mm.
Yeah. Mm,
Um,
so
so do you have numbers, but you mean the benefits? Or what does it cost? What do you gain? Even maybe it's probably too early, but do you
yeah.
have any projection regarding the quantity that you could produce, the price? Who would be your main target? I know in
Yeah.
the maritime industry, there will be a demand for that, but not.
So on the market side, we know that the methanol could be used as a feedstock for cars, and it could also be used as valuable feedstocks for converting it to some other product also. And
Okay, like okay, chemistry industry.
yes, so more likely as feedstocks. So as the reactant for production of other compounds. And the conversion efficiency, I'm currently working on it. So, and even the cost. So those are the two components which I need to work on, because it's still at very lab and early stage, I would say.
Okay, so you are really in the R&D phase.
Yes.
So are you planning to have some prototype or some pilot
Yes.
laboratory or pilot plant or something like that?
Currently, we are on the lab scale, so we will need to make it in the pilot scale and then move further. So, yeah, it's part of my thesis project. So if I have to move further, that
And,
would be.
and do you have numbers regarding the energy you need to produce, let's say, 1 kilogram of methanol?
Yes. So we in this process we only require a source of visible light, which is actually the sunlight. And the
Okay.
photocatalyst itself activates, and photocatalyst we use it in very small amount. So we use the photocatalyst in very small amount, so that would be very less expensive, um, and we just need visible light, so that we could even use the sunlight for the process. That's why it's known as the photocatalytic. So the just for activating the photocatalyst. So we do not have much requirement of cost actually.
Yeah, that would be. I understand, and
Yeah,
you are at the early stage, but that would be really something interesting to know.
yeah,
And at the end, so in your process, you do not need any energy. It's just the solar energy,
yes, that's right.
but then you need some kind of equipment to
Uh,
convert the solar energy into well, the energy that is going to the water to
um,
absorb the CO2.
mm, yes, so uh, we actually just use the solar energy. So when the solar energy falls on the photocatalyst, it gets activated, and that's where the conversion takes place. So we do not use any other kind of or external energy for the conversion.
Yeah. Okay.
We just use two chemicals at present, because I'm using this DI water. So in that case, I have to dissolve the CO2 inside the DI water. So for that we use triethanolamine, and then we use very small amount of acetonitrile and acetonitrile dissolved and water. So that's all the process. So we do not use any external source of energy in our process.
Okay. So when
So
you're
all the
talking about the
chemistry takes place behind the photocatalyst, the catalyst which we develop, or because it's like semiconductor photocatalyst. That's
okay,
the
so
one
it's like a
which plays the role.
is it like a solar panel or
No, it's not like a solar panel, but it's like powdered powdered material.
okay, it's really it's a chemistry
Right,
reaction,
right, right. That's right.
and then you use a solar energy
Right.
to extract the CO2 from the sea.
Actually,
Um,
we use the solar energy to convert the CO2 to methanol. So the reaction takes
okay,
place on the
okay,
surface of the
you do not.
photocatalyst.
Hmm.
Yeah.
Okay, and then in term of occupation of the surface, what you need, let's say you have a 10 square meter of photocatalyst.
Right.
Do you know what would be the production of that kind of equipment? Or maybe
Sorry.
it's too early.
Can you just
I
repeat?
guess um, it's just from a production perspective, because at the end, you will have to know what would be the production
Right,
of.
right,
So if you have the equipment where you use the photocatalyst reaction,
right.
is it like something you put that in? It has a certain surface or surface, a certain area, I guess.
Yeah, so usually it's a reactor. So we put like a small amount of water along with the photocatalyst, and then
Okay, it's gonna be done in a reactor. So
yeah,
you
yeah,
take
yeah.
the water from the sea,
Yes.
then you put it in a reactor,
Yeah,
and then you have the reaction.
yeah.
Okay, I see.
So
Um,
on the lab scale, maybe I can just show the reactor. So so we just use this kind of reactor at present. Yeah. So over
okay,
here we have the reactor, and we just have a cords. We have just a cords cover in order to actually focus the sunlight, focus the visible light. So we use a device which actually converts the UV light to visible light, and then we concentrate the light on the photocatalyst, which is here, and then we use syringe to collect the samples over period of time. That's how the process works.
Okay, and then so you're really at the lab stage
Yeah.
for now. Do you
Yes.
have are you also in the patent process?
Currently we are not, since we are still working, so it will take some time to go on the patent process.
Okay, but that's something I would strongly encourage you if you have really something which is um authentic or if which is really original, then that would be a good
Yeah.
idea
Yeah.
to patent. Um, so, I mean, your invention is of interest,
Yeah.
not
Thank you.
directly from myself because I don't have any shipping. I don't have any vessels. And, I'm just working with the ship owners and
Yeah.
people who are operating vessels.
Yeah.
But I know there is a demand for that kind of new. What you are going to produce is a kind of biofuel.
Right.
There is different appellation. We could call it e-fuel, but e-fuel is something, the fuel that is produced from what we call green energy, green electricity.
Yeah.
But yourself, it's not directly electricity, so it's not really e-fuel, but it's also not really a biofuel because you don't take any biomass. Maybe
Right.
you need to find a new name, a new appellation. But I mean, it's a biofuel. I guess you're in the biofuel. So
Mm,
you would need to know what is your let's say you have a reactor. So okay, this is a lab reactor, but you can have a larger reactor, which could be like a pre-industrial reactor,
right.
and see what would be the production of, because at the end, that's what we want. How many kilogram of methanol can you have with one reactor?
Yeah. That's right. That's something we need to work on, but it's like thesis project, so we do not have a lot of funding in order to actually do that. So we have to do it
Oh yeah,
very,
but I think
yeah, later
you
on.
should.
We try to do it. We try to get the funding, and then we would work on it.
Yeah, but even with your lab equipment,
Yeah.
you should be able to at least to have your first methanol production. You should have some numbers, see what would be the potential of that.
Yeah. Right.
And that, do you have any idea? Let's say you have a reactor, you put 1 liter of
Uh,
seawater, and then after 1 hour, what is the
yeah.
quantity of methanol?
Yeah, we tried doing it, and we did it on 50 ml of DI water, 50 ml, and with 50 mg milligram of photocatalyst, and running it for 8 hours, and we got something like 40 ppm.
40
So
ppm of methanol?
yeah, because it's very slow reactions, we're still trying to improve it on the efficiency, and also
Okay,
to
so
put,
so
yeah.
it's either you have a lot of reactor, or either you have a lot of time, and then at the end you have
Yeah.
so you get when you say 50 ppm of methanol. So and at the start you had 15 milliliter of seawater.
Yeah.
Okay, so it's for now it's a really small production.
Yes. So we work on it more and more in order to optimize the photo catalyst. So our main target is actually now to understand the mechanism, because there are other products which are produced, such as formate, which is the intermediate product, and also we get like some gases kind like methane or carbon monoxide. So those are like the byproducts. So our work is to actually now first understand the mechanism, what's going on, and then improving on the mechanism to focus more on the target product.
Okay, so the interest of your invention is that okay, maybe it's a slow process,
Yeah,
but then it's free.
yeah.
There is no. But when say the catalyst, so you have some uh, chemical or some reactives that you need to use.
The photocatalyst for the
Yeah,
photocatalyst. Yeah, it is acetonitrile and triethylamine,
but
triethanolamine.
if it is just a catalyst, then you do not really consume this product. It's just there to activate the chemical reaction.
Yeah, it's just to activate the chemical reaction.
Okay, so at the end, you do not consume energy, you do
Mm,
not consume chemical product. So
at the
that's
end, the photocatalyst does not get consumed. Yeah, that's right. So we have tried using the photocatalyst again and again, like 4 to 5 times. So we can just recover it and use it again.
okay. So that's interesting.
Yeah,
I think it's interesting, but then the only thing that you need to understand what is the production of
yeah,
like a lab plant or a pilot plant or something.
yeah. That's what we aim to do.
Do you have any timetable, or do you think?
Uh,
Did you have any idea of?
Currently, we do not have any timetable on it because um, we just came up with the idea to commercialize it. We did not we have the plan to do it in what process we can do it, but we need equipments for doing it and various other challenges with the process. So it actually depends on the funding if we receive. So once we receive the funding, then only we can go on with the next level. Yeah.
So the funding with the OSP.
Yes, maybe OSP or from some other sources too. Yeah.
Yeah, because OSP is just well,
Mm,
it's a nice to have, but it's not enough to. You won't go very far with the OSP
yeah.
money. I mean,
Yeah.
that's for sure. Yeah. So are you? Do you have a company now when you
No,
say the ZAB? No, it's
no.
not at that stage now.
It's not at that stage actually.
Hmm.
Yeah.
Okay. Well, that's interesting. I mean, to me, this is interesting because I'm looking for any solution that bypass